Namaste, myself Gaurav Goyal from the Faculty of Physiotherapy and Diagnostic in the discipline BSc RT. I feel Gaurav Goyal. In the previous session, we had discussed about the gas tube or historical X-ray tube that has some limitations. So the Cooley's tube has developed by the scientist Cooley's. Cooley's tube has some advantages. So it is now more acceptable X-ray tube or mostly used in any radiation applications. So today we are going to discuss about the Cooley's tube or modern X-ray tube and their equipments or components. Okay, let me discuss about the Cooley's tube. Before discussing about the tube, we are going to discuss about thermionic emission principle. Thermionic emission or thermionic emission principle. Thermionic emission principle. Thermionic emission principle. Thermionic emission principle. In this, according to the principle, any filament, any cathode filament, when cathode filament is heated to incandescence, the filament emits electrons in a large amount. When a metal is heated, metal means filament material. In the Cooley's tube, the material is used a tungsten filament. So the metal is tungsten. When it is heated, it emits large amount of electrons that is stuck on the target. So the thermionic emission principle, the principle is defined as when a metal is heated at high temperature. Metal is heated at high temperature. Metal is heated at high temperature. It emits a large number of surface electrons. The large number of surface electrons in the tube. In this type of tube means Cooley's tube, the filament is in spiral form of tungsten wire. Tungsten wire. So you can see what is thermodynamic emission principle. The Coolidge tube is based on thermodynamic emission principle. Based on thermodynamic emission principle. So when the electrons are emitted from the cathode filament to collect these electrons and another electrode is used that is at positive potential. That electrode is at positive potential. To collect these electrons, and another electrode is used that is at positive potential. That is also called a target. The potential by which all these electrons are collected, that is called saturation potential. All the Coolidge tube is worked on saturation potential. After that, the potential increases, then there is no change in the current flow within or inside the X-ray tube. So saturation potential is a threshold or maximum potential at which all electrons are collected by the target. Next, so the potential by which all electrons are collected by the anode, collected by the anode. The potential is saturation potential. So in these tubes, in the Coolidge tube, there is no production of electrons by ionization. So the electrons are produced only by the thermionic emission principle. After that potential, if the potential applied potential increases, there is no change in the current flowing in X-ray tube. to produce the heat or temperature in the filament, the applied voltage is 10 volt and the current is in between 2 to 4 ampere. 2 to 4 ampere that is used to produce a temperature or heat the filament. So these are the advantages that after the saturation potential there is no change in the current flow. So there is no collide or collision of electron or surface electrons with gases or any material in the tube. This is the advantage. So the components of the Coolidge tube is first component is cathode